This question is on vector addition for an object at equilibrium. It is a pretty tough question, but you will realize that if you quickly sketch out the vector diagram, it will be very easy to see and convince yourself of the answer. So the answer to this is A. When we increase the angle theta, both the values of P and T, these two forces, must increase in its magnitude. So we must first realize that the object is in equilibrium, and that, as usual, means that when we draw a vector diagram, the vector diagram has the same starting point and ending point. In other words, we should expect a closed diagram. So we can do a quick sketch for to add up the three vectors. So we start with the starting point. I'll start with the downwards weight vector. I will carry on with the diagonally upwards tension vector at the angle theta to the vertical. And my last vector is force P sideways towards the left, and I note that I must end this vector at the starting point. Now, if I force myself to repeat this diagram again with a bigger theta, this is what I will get. So I'll do the same process. I will start with a downwards weight, no change as of now. But when I start to add in and draw in my tension force, the diagonally upwards vector, I draw it such that the angle theta is much bigger. And lastly, I complete the diagram by drawing a perfectly horizontal line to represent force P, and this line, this force vector, must end at the starting point. And notice that when I increase the angle theta in my second vector diagram, it automatically forces you to draw a longer T vector and a longer P vector so that you can maintain the closed vector diagram. So this is the reason why when the angle theta becomes bigger, the forces P and T will also become bigger. Seen very clearly now once you sketch out the two vector addition diagrams.